So we are studying about the structure of benzene, how the structure of benzene was derived by Kekulé. So Kekulé gave the structure of the benzene in 1865. So by observing certain points or some reactions, he gave the structure of the benzene, which nowadays we are studying as resonating structures, like this. So we are studying the resonating structures of benzene. But how it was given by the Kekulé? It was given by the Kekulé after studying certain observations. After the observations made by him. So first observation, first point, the molecular formula of benzene. Molecular formula of benzene was found to be C6H6. So this formula indicates high unsaturation in the benzene molecule. Because if you take the alkanes, so alkanes highly saturated compounds. So alkanes general formula is CnH2n plus 2. Alkenes general formula is CnH2n. Alkynes which are having triple bond, general formula is CnH2n minus 2. So if you put n equal to 6, as here carbons are 6, then we get C6H, 6 into 2, 12 plus 2, 14. In case of alkenes, C6H12 we are getting, 6 into 2, 12. Here C6, alkynes order, C6H10 we are getting, 6 into 2, 12 minus 2, 10. So you know alkanes contain single bond, carbon-carbon single bond, alkenes contain carbon-carbon double bond, alkynes contain carbon-carbon triple bond. So double bond, the compounds having double bond and triple bond are unsaturated compounds. So in the unsaturated compounds, number of the hydrogen atom is decreasing. You see C6H14 C6H12 alkynes and C6H10 is there. So number of the hydrogen atoms is decreasing as the unsaturation increases. As the double bond comes, number of hydrogen is decreasing from this. Similarly, triple bond again number of hydrogen atoms are decreasing. So decreasing the number of the hydrogen atoms indicates the unsaturation. So if you take the benzene formula C6H6, so what it indicates, number of the hydrogen atoms are again less than the alkynes. So it indicates the high unsaturation in the molecule. Okay. So this benzene molecular formula of benzene is not at all, cannot be compared with the formula of the alkane, alkene or alkynes. It is entirely different. So there is no comparison of the benzene with the alkane, alkene or alkynes. But as the number of the hydrogens are very less, so which indicates that it is highly unsaturated compound. First it was assumed that it is highly unsaturated compound. Then second point, Kekulé studied second point. The benzene on reacting with the ozone formula is O3. It forms triozonide compound. Triozonide compound means 3 ozone molecules reacts with the benzene. So ozonide, if you remember, while studying the alkenes, we studied about the ozonide. So if you take the ethene, CH2 double bond CH2. So ozone adds at the double bonded carbon atoms. This bond will be broken completely. So it gives the ozonide, CH2 and here O1O and 2O like this. The structure is ozonide. Similarly, if you have propene, CH3, CH double bond, CH2 is propene. It reacts with the ozone and it gives CH3. Then CH again O, CH2O. This is propane ozonide. So what it indicates, ozonide is formed, one molecule of O3, ozone is added at the double bonded carbon atoms. So as it forms, benzene forms triozonide, means 3 double bonds are present in the benzene structure. So second point, benzene with ozone forms triozonide compound. So it indicates, what it indicates? It indicates presence of 3 double bonds, 3 carbon-carbon double bonds. This is second point. Then third point is about the substituted benzene. So benzene on reacting with the chlorine or bromine, it forms only one monosubstituted product. So only one monosubstituted product means all the carbons in the benzene, they are equal. It indicates all the carbons in benzene are equal. Carbon and also hydrogens are identical. Therefore, it forms only one monosubstituted product. So by observing all these, by making all these observations, by observing all these points, so Kekule gave the structure for the benzene as 6 carbon atoms. 6 carbon atoms forming the hexagonal structure, and each carbon attached to the one hydrogen. Each carbon attached to one hydrogen. Then alternate, and that cycle ring, it contains alternate single and double bond, because valency of carbon should be satisfied, 4. So there alternate single and double bonds are present in the benzene ring. So what that is, he gave the pi electrons, they have the oscillating nature. The pi electrons, they have the oscillating nature. He gave the cyclic compound, cyclic arrangement of 6 carbons with the alternate single and the double bond, and each carbon contains the one hydrogen. Or the bond line structure of this benzene, it is written as like this. Okay. Now in the structure, if it forms the disubstituted compound, there are 2 possibilities of forming the disubstituted compound. So 2 possibilities means disubstituted, 2 hydrogens are replaced. So suppose if this hydrogen and this hydrogen is replaced by bromine, Br and Br. Both Br are present. In between they are attached to the carbon atom which is having the double bond, means there is possibility of the 4th point. You observe, when the disubstituted product is formed, there are 2 possibilities of forming the disubstituted product. If you take the structure of the benzene like this, if we take the structure of benzene like this, when it forms the disubstituted compound, then there are 2 possibilities of the structures. So in the first structure, the 2 substituents, like if there are 2 substituents are bromine, then Br, 2 Br. In the first structure, 2 Br attached to carbon-carbon double bond. Okay. And in the another structure, in the another possible structure, 2 Br, they are attached to the, if this hydrogen and this hydrogen are replaced by Br. Then 2 Br are attached to the carbon-carbon single bond. Like this. 2 Br are attached to the carbon-carbon single bond. Here 2 Br atoms are attached to carbon-carbon single bond. So when it forms the disubstituted, when benzene forms the disubstituted product, if we take the structure, hexagonal structure containing alternate single and double bond, then there are two possibilities of the structures, disubstituted structures. So in one structure, 2 Br are attached to the carbon-carbon double bond. Here 2 Br attached to the carbon atom which are having the double bond. In another structure, 2 Br atoms are attached to the carbon atom which are connected with the single bond. Okay, but this is ortho-dibromo. It is ortho with respect to this. So ortho-dibromo benzene, and this is also ortho-dibromo benzene only. But in one structure, dibromo, 2 Br are attached to the carbon of the having the double bond. In other structure, 2 Br are attached to the carbon of the single bond. This is also ortho-dibromo only. So, but experimentally it is observed that it gives only one ortho-dibromo benzene. Actually, when experimentally when the benzene reacts with the bromine, it gives only one ortho-dibromo benzene. So it indicates only one ortho-dibromo benzene. So it indicates that the double bonds which are present in the benzene, they have the oscillating nature. So therefore Kekule gave two structures in which the pi electrons are oscillating in the benzene. So for example, like this. Here in the first structure, if you give the numbers 4, 5, 6, in the first structure, double bonds are between 2, 3, 4, 5 and 6, 1 carbons. In the another structure, double bonds are between 1, 2, 3, 4 and 5, 6 carbons. So Kekule gave two structures for the benzene, oscillating structures in which pi electrons have the oscillating nature. Okay. So each carbon contains hydrogen and all the 6 carbons are forming the hexagonal ring, and they have the alternate single and the double bonds. So we studied about the structure of the benzene or structure elucidation. Elucidation ಅಂತಂದ್ರೆ proof. How the structure of the benzene was proved. Elucidation of the structure of the benzene. Okay. Means in the last point I told you, Kekule gave two structures because of the oscillating nature of the pi electrons. He gave two structures for the benzene. So elucidation of structure, explain structure of benzene for 3 marks. If it is asked, you should write up to here. Illi mata baribeku 3 marks kelidralla. Okay, means 4 points are there. By observing those 4 points, he gave the structure. Okay, then when there are two structures for the benzene like this, then how it becomes stable? So the stability of the benzene was explained by the concept called as resonance. So resonance of the benzene and stability. Resonance and stability of the benzene. when he gave two structures, stability of benzene. So how it becomes stable? So stability of the benzene, it was given by the concept of the resonance. It is according to valence bond theory. So according to valence bond theory, here the these pi electrons, the pi electrons are not fixed, they are not localized between two carbons. They are moving throughout the ring, means they are delocalized. Delocalized ಅಂದ್ರೆ one ಕಡೆ ಫಿಕ್ಸ್ ಇರಂಗಿಲ್ಲ. Delocalized inside the hexagonal ring. Hexagonal ring. They are delocalized. So they are not fixed in between 1, 6, 4, 5, 2, 3 in this structure, and they are not fixed between 1, 2, 3, 4, 5, 6 in this second structure. They are moving throughout that 6 carbon hexagonal ring. So they are for all the 6 carbons. They are related to all the 6 carbons. Therefore, it is benzene was considered as the resonance hybrid of these two structures according to valence bond theory. So, because of that, it becomes stable. So, resonance hybrid, it was given as the two structures, these two structures are given by Kekule, and then the 3 pi electrons are oscillating as the dotted ring or as the circle, small circle we can show. So this is resonance hybrid in which the 3 pi electrons under 3 pair of pi electrons, 6 electrons, they are moving, oscillating here, and they are belonging to all the carbon atoms. Okay, so benzene is represented as the resonance hybrid of these two structures. So this explains about the stability of the benzene. Therefore, that benzene becomes stable as the electrons are moving here. Okay, they are delocalized. But there are limitations about the Kekule structure of the benzene. It was given by Kekule, and there are 2 limitations. So according to Kekule, benzene contains 3 double bonds. So 3 double bonds, it indicates that double bond means that benzene should undergo addition reactions, because you know the unsaturated compounds which have the double bond or triple bond, always they undergo addition reactions. So benzene should undergo addition reactions as it contains 3 double bonds, carbon-carbon double bonds, but it undergoes substitution reactions. It undergoes substitution. Substitution reactions are the characteristic reactions of the saturated compound, but it undergoes substitution reactions. So this limitation, it was overcome by the theory, that is the molecular orbital theory. Okay. So I told you, due to the resonance hybrid, it is stable, but it is highly stable. Benzene is unusual, highly stable. So I told you there are limitations about the Kekule structure. First limitation is it undergoes substitution reactions. Instead of addition reactions, it undergoes substitution reactions, though it contains the 3 double bonds. Another limitation is its unusual stability. It is not explained in the by this Kekule structure. Only he explained that there are 3 alternate double bond and single bonds. And resonance theory, according to resonance theory, these two, instead of writing these two structures, benzene can be represented as the resonance hybrid of these two structures. So it is stable. But unusual stability, maximum stability, unusual stability and maximum, highly stable. Benzene is highly stable. So that unusual stability of benzene is not explained here. The theory fails to explain the unusual stability of benzene, and instead of the addition reactions, it undergoes substitution reactions. The reason for undergoing substitution reactions is not explained. Reason for substitution reactions instead of addition reactions is not explained here. Okay, so it was explained by the molecular orbital theory. The next theory, it is molecular orbital theory, which explains the unusual stability of benzene, and also it explains why the benzene undergoes substitution reactions.